We'll get back to the notes here. So we're on problem 36. We're talking about transformations. There's three types of transformations. There's shifting, reflecting, and then vertically or vertical stretching or compressing. So in problem 36, it says if the point -7, 4 is on the graph of y equals f of x, which of the following points must be on the graph of y equals 3 times f of x? Okay. Well, if I throw a 3 in front of the function, all I'm doing is I'm multiplying all the y values by 3. Okay, so this point here, -7, 4, that's going to be at -7, 12. Okay, so my answer would be C with that one. And all the points that would be on the graph of f of x, I'd have to multiply them by 3. All the y values there, okay? All right, problem 37. We want to use transformations to sketch the graph of f of x equals -2x squared plus 3. Okay, so there's going to be some problems like this coming up in kind of the early part of chapter 3 when we talk more about quadratics. So we're going to start off with y equals x squared, okay? And I got these points on the graph of y equals x squared. So here's 0, 0, 1, 1, -1, 1. When x is 2, 2 squared is 4, right? So 2 4s on the graph. When x is -2, -2 squared is 4. So there's -2, 4 on the graph. Okay, and I got this parabola facing upward. So if I put a -2 in front of x squared, then that means I'm going to have to vertically stretch out the graph by a factor of 2, and we're going to have to flip it upside down. Okay, now all I'm going to do is I'm going to multiply all the y values by -2 to get the new graph. Okay, so 0, 0, that's not going to go anywhere. That's going to be at 0, 0. 1, 1, when I multiply the y value by -2, that puts me at 1, -2. -1, 1, when I multiply the y value by -2, that'll put me at -1, -2. 2, 4, when I multiply the y value by -2, that'll put me at 2, -8. That's off the scale that I've got there. That point would be there, though. And then -2, 4, that's going to be at -2, -8. That point, again, is off the scale that I've got, but we'll stick with these 3 labeled points for the next graph there. And so I got this parabola, and it's facing down. Now, I vertically stretched out the graph, so that meant that the graph got closer to the y-axis on both sides. Okay? So then the last thing would be to add 3. Okay, so the equation I'm redrawing here, and this is my answer, I got y equals -2x squared plus 3. Okay, so what that means is that I'm going to have to take this graph 2, and I'll have to shift it up 3 units with the plus 3 at the end. Okay, so all the points are going to move, right? 0, 0 is going to be at 0, 3. 1, -2. When I go up 3 units, that'll put me at 1, 1. And -1, -2, when I go up 3 units, that puts me at -1, 1. Okay, so then I draw this parabola, and that'd be the graph of this curve there. Okay. I mentioned this very briefly in the last video, but knowing transformations is very important because it's like you already know the answer. Okay, like if I already know that I'm going to vertically stretch out this graph by a factor of 2 and also flip it upside down and then shift it up 3 units to get this graph here, which is what I did, then that's huge over somebody who doesn't know that information and who's stuck point plotting. So again, knowing transformations, that's very important. Along the way, we're going to add more basic functions to the group. Okay, in the notes in at the end of section 1.1 and 1.2, I had there's a worksheet there. It's where they just kind of start you off with what they're called the basic functions, okay, and then along the way we're going to add more functions to that group there, okay. Problem 38. We have the graph of y equals f of x, that's shown right here. In part A, I want us to graph y equals f of x plus 2 minus 2. And then in part B, we'll graph y equals 1/3 times f of x. Okay, so in part A, we need to graph y equals f of x plus 2 minus 2. Well, that means that I'm going to have to take this graph here, and there's going to be two shifts that happen. So if I replace x with an x plus 2, that means that I'm going to have to go to the left 2 units with all these points. Okay, so all these points here, bump them over to the left 2 units. And then the minus 2 means I have to shift down 2 units. Okay? Now, if you're only shifting a graph, it doesn't matter the order that you shift. Like I go down 2 first and then to the left 2 second. So I get the same result there. So let's see where these points are going to go. Here's 0, 3. When I go down 2 and to the left 2, that'll put me at negative 2, 1 on this graph here. Here's 2, 3. When I go to the left 2 and then down 2, that'll put me at 0, 1. Okay, here's the point 4, 0. When I go down 2 and to the left 2, that puts me at 2, negative 2. And then here's the point negative 4, negative 3. So when I go to the left 2 and then down 2 with that, that's going to put me at negative 6, negative 5. Okay, and so I draw this curve there, and all the points are going to move. Okay, so it's important to keep track of where things are going there. Now, part B, we want to sketch y equals 1/3 f of x. Okay, so all I'm going to do is I'm going to multiply the y values by 1/3. And I'm going to vertically compress the graph, or vertically smash the graph there. So this graph, I imagine kind of hands pulling on the y-axis, smashing this down. That's going to force the graph to split further from the y-axis on both sides. Okay, so again, I'm multiplying all the y values by 1/3. Okay, so here's the point 0, 3. When I multiply the y value by 1/3, that's going to go to 0, 1. Okay, here's the point 2, 3. When I multiply the y value by 1/3, that's going to put me at 2, 1. Here's the point 4, 0. When I multiply the y value by 1/3, that's not going to change anything. That's going to still be at 4, 0. Okay. And then here's the point negative 4, negative 3. When I multiply the y value by 1/3, that point is going to be at negative 4, negative 1 on the new graph. Okay, so all the points are going to move. And here's my answer there to part B. Okay. Problem 39 is where I have a function and they want us to compute f of negative x and simplify that. We'll do that in part A, and then part B, we're going to compute negative f of x and then simplify that. Okay, so f of negative x means that wherever I see an x in f, there's a couple of x's shown there, I'll need to replace those with negative x. Okay, so I got negative x cubed plus 2 times negative x squared. And by the way, be sure to have the parentheses around the negative x's. okay, because negative x squared is not the same thing as negative x squared with parentheses. Negative x squared with parentheses is the same as x squared. Negative x squared without parentheses, that's the same thing as negative x squared. Okay, so I get two different things there. Negative x cubed with the parentheses, that's the same thing as negative x cubed without the parentheses. I got a negative in front of that, so I'm going to have x cubed leading off and plus 2x squared. Okay, in part B, I want us to find negative f of x and simplify. So negative f of x means to take negative the whole thing for negative x cubed plus 2x squared. And when I distribute this negative, I got x cubed minus 2x squared. Okay? Now in part C, it says, is the function even or odd or neither? Okay? If f of x is equal to negative f of x, then you have an even function. And why we care about that is because an even function is always going to be symmetric to the y-axis. Okay, so if I spin the graph about the y-axis, I'll get the same picture. And ideally, you know, that would reduce the amount of point plotting that I would need to know if I had an even function. An odd function is where f of negative x is the same thing as negative f of x. Okay, and why we care about that is because an odd function is always symmetric to the origin. Now, symmetric to the origin just means that any point that's on the graph, x, y, negative x, negative y is also going to be on the graph. Okay, so again, it kind of helps me with point plotting because it would reduce the amount of point plotting that I would need, you know, if I knew that I had a graph that was symmetric to the origin. Okay, so here's this function, f of x. Is it true that f of x is the same thing as f of negative x? Like, are these the same thing? No. The first term is different, right? So, in other words, I don't have an even function. Okay, f is not even. Now I want to know if f is odd. What does it mean to be odd? It means that f of negative x is the same thing as negative f of x. Okay, so are these two things the same thing? No, they're not. You know, the sign is different there. So I don't have an odd function either. Okay, f is not an even function, f is not an odd function, so f is neither even or odd. Okay, and as far as any symmetry goes on this graph, there wouldn't be any symmetry, right? Now, just a fact about functions says that, you know, the majority of the functions that you'll ever work with are not going to be symmetric to anything, okay? But it's still nice to know if we have something that's symmetric to the y-axis or to the origin, you know, because that reduces the amount of point plotting that I would need, okay? All right, we'll go ahead and stop the video right there, and I'll pick up with problem 40 in the next one.